Hello children, welcome back to our class. In the previous class we discussed about quadratic equations. In that chapter quadratic equations we discussed how to find the roots of a quadratic equation by different methods. They are namely factorization method and completing square method and quadratic formula method, and of course some strategies we discussed for some special quadratic equations. And now let us try to understand the particular methods and moreover the suitable methods by some examples. Okay, yeah, let's have a look. And this is quadratic equations, right? Quadratic equations, right? We are going to discuss a few set of examples in this. For example, the first one is solve 1 by a plus 1 by b plus 1 by x is equal to 1 divided by a plus b plus x. How to solve this quadratic equation? Of course, it is not in the standard form of a quadratic equation, but I would say that it is a quadratic equation. But how can I say that it is a quadratic equation? And moreover, what are the strategies to solve this particular equation? We will have to think about that. Okay. See, left hand side we have three terms which are fractions, and right hand side there is only one fraction. So, if you just take left hand side completely and find LCM, then you get three terms. So that by those three terms I will get some huge fraction you will get in left hand side. So, just to avoid, let us try to balance this. 1 by a plus 1 by b plus 1 by x is equal to 1 by a plus b plus x. I will do one thing, I am going to transpose this 1 by x towards right hand side. Then the problem will become 1 by a plus 1 by b is going to be 1 divided by a plus b plus x plus 1 by x would be minus 1 divided by x. And then if you find the LCM here, b into 1 is equal to b plus a into 1 is equal to a divided by a into b is going to be ab, which is equal to x into 1 is equal to x minus 1 into a plus b plus c. Since minus is there, definitely you will have to keep a bracket, a plus b plus x whole divided by a plus b plus x multiplied by x, right? Let us try to simplify. This is b plus a by ab is nothing but a plus b divided by ab, and if you open up the bracket here, it is going to be x minus into a minus into b minus b minus into x minus x whole divided by a plus b plus x multiplied by x, right? You can cancel this x, and remaining terms are a plus b divided by ab is going to be, this is minus a minus b. If you take one minus common from both the two terms, then minus of a plus b divided by a plus b plus x multiplied by x. See, there is a single term in the numerator and single term in the denominator, in the numerator of the right hand side also. So that if both the two terms are same, then we can cancel them. So a plus b once and a plus b once. And now by cross multiplication, or you can reverse both the fractions, anything is okay. This entire term into 1 is equal to this entire term. Similarly, ab into this minus 1 is equal to minus ab. Now I am going to write that x into x is equal to x square plus x into a is equal to ax plus x into b is equal to bx is equal to ab into minus 1 is equal to minus ab, correct? So transposing minus ab towards left hand side, then it is going to be x square plus ax plus bx plus ab is equal to 0. See, it is easily, it can be easily factorized, because from the first two terms you can take maximum of x common. From third term and fourth term, maximum of b can be taken common. So then x square plus ax x can be taken common, so that x times remaining x plus a, from third term and fourth term maximum of b can be taken common, so that plus b times remaining here x and here a. So, x plus a is going to be 0, right. Totally we have x plus a common, so that you can take x plus a common into x plus b is equal to 0. Since the product of two terms equal to 0, either first term equal to 0 or second term is equal to 0. So, that you can write it as x plus a is equal to 0 or x plus b is equal to 0. If x plus a is equal to 0, x is equal to minus a, or x plus b equal to 0, x is equal to minus b. Therefore, the possible values of x are going to be x is equal to set containing minus a comma minus b, right. So, this way we can easily solve this kind of quadratic equations, right. 1 by a plus 1 by b plus 1 by x is equal to 1 by a plus b plus x. Then the values of x are going to be minus a comma minus b, right. Okay. Let us move on to next example, that is question number 2. Solve for x. Of course, the previous one also solving for x only. X square plus a divided by a plus b plus a plus b divided by a times x plus 1 is equal to 0. I am going to solve this quadratic equation. But if I want to solve this quadratic equation, what should I do? Because a divided by a plus b here and this is a plus b divided by a. So, if I want to take something common, it is not possible, because from the first two terms x square a by a plus b into x, so x only can be common. Okay, if I take x common, then x times x plus a by a plus b, but the other two terms are a plus b by a plus 1. So, from a plus b by a into x plus 1, I cannot take anything common other than 1. So, later on there are no common factors. So, then definitely I will have to think about this. This is a divided by a plus b and this is a plus b divided by a. What kind of terms both are? A divided by a plus b divided by a. Yes, both are reciprocals. So, what are there? If they are reciprocals, then what can we infer about that? If they are reciprocals, then their product is going to be 1. So, 1 is already there, right. So, that I am going to write this one as x square plus a divided by a plus b plus a plus b divided by a times x, and I am going to write this one as a divided by a plus b multiplied by a plus b divided by a is equal to 0. Now, you see this is in which form? Basically, suppose if I consider a divided by a plus b is equal to some alpha and a plus b divided by a is equal to some beta, then this is going to be in the form of x square plus this is alpha and this is beta times x plus alpha into beta is equal to 0. Yes, this is in the standard form of roots, where the roots are going to be minus alpha and minus beta. We had a discussion about this, right. So, otherwise, if you do not get any idea, then this is x square plus alpha plus beta into x plus alpha beta is equal to 0. If you factorize this, then it is going to be x square plus alpha into x is alpha x plus beta into x is beta x plus alpha into beta equal to alpha beta, which is equal to 0, right. From the first two terms, you can take one x common, remaining x plus already x taken common alpha, plus from these two terms you can take one beta common, remaining x plus alpha is going to be 0. So, totally x plus alpha is a factor, right. So, that x plus alpha is common factor into this is x plus beta is equal to 0. So, x plus alpha into x plus beta equal to 0, then easily we can say that what are the values of x. Therefore, the values of x are minus alpha comma minus beta. Of course, you are aware of this, but I am showing you once again. If any quadratic equation is in the form of x square plus alpha plus beta into x plus alpha beta equal to 0, then the roots are going to be minus alpha and minus beta. I will write that information here itself. X is equal to minus alpha comma minus beta, right? When the quadratic equation should be in the form of x square plus alpha plus beta into x plus alpha beta is equal to 0, right? So, directly you can write the roots are minus alpha comma minus beta. This is just I showed you how did I get those roots x is equal to minus alpha and minus beta. So, moving back to our problem, see here our problem is x square plus a divided by a plus b divided by a into x plus a by a plus b into a plus b by a is equal to 0 is in the form of x square plus alpha plus beta into x plus alpha beta is equal to 0. So, what is there in the place of alpha and what is there in the place of beta? Yes, therefore, x is equal to minus alpha comma minus beta, where minus alpha is going to be minus, in the place of alpha you have a divided by a plus b, and minus beta is going to be a plus b divided by a. So, minus a plus b divided by a. So, these are the roots of the given quadratic equation, means these are the values of x. You understand? So, when you find some quadratic equations, then without actually performing any calculations, we can easily figure out the roots of a quadratic equation. But you will have to observe that whether the quadratic equation is in this form or not. X square plus alpha plus beta into x plus alpha beta is equal to 0 or not. Okay? And let us solve one more quadratic equation. Okay? So, that is now solve for x. So, what is that quadratic equation here? Quadratic equation is solve for x. Now, my equation is little different, that is x square minus of root 2 plus 1 times x plus root 2 is equal to 0. Okay? This is one quadratic equation. See here in this quadratic equation, is it possible for me to get the roots without performing any calculations? So, definitely I will have to think, because here root 2 plus 1 as sum of the zeros and root 2 is in the place of product of the zeros. If these two are two zeros, for example, root 2 and 1, and here it should be root 2 into 1 should be there. Obviously, root 2 into 1 is equal to root 2 1, you know? Yes. So, you can write it as x square minus of root 2 plus 1 times x plus root 2 into 1 is equal to 0. Is in which form? Is in the form of x square minus of alpha plus beta times x plus alpha into beta is equal to 0. You know this, if this is the quadratic equation, then what are the roots? Yes, the roots are going to be x is equal to alpha comma beta, right? What is alpha, what is beta here? Therefore, alpha is equal to, in the place of alpha you have root 2 and in the place of beta you have 1. Therefore, the roots are going to be alpha is equal to root 2 and beta is equal to 1. So, this way you can easily find out the roots of any quadratic equation, right? Okay. Let us move on to one more example, that is solve for x. What is that quadratic equation? That quadratic equation is going to be x minus 1 divided by x is equal to 3, where x is not supposed to be 0. Okay? X minus 1 by x is equal to 3, but x is not supposed to be 0. If you once observe this given problem, why this condition has been given? X is not equal to 0. What happens when x is equal to 0? X is equal to 0, here it is okay. But if x is equal to 0, 1 divided by 0 is undefined. That is why x is not supposed to be 0. Okay? So, that was the condition to be the given problem defined. Okay? So, that is why that condition is given, right. So, how are you going to solve this? First of all, you will have to understand one thing, that x minus 1 by x is equal to 3. As you know that x and 1 by x are reciprocals, and difference between a number and its reciprocal is equal to 3. Will you be able to guess such numbers? Maybe it is not that easier. Okay. Let us try to convert this into the standard form of quadratic equation. Okay. Then write this x as x divided by 1. Then it is going to be x into x is equal to x square minus 1 into 1 equal to 1 divided by 1 into x is equal to x is equal to 3, means 3 divided by 1. Since we have two equal fractions, of course you will have to cross multiply. X square minus 1 into 1 is going to be x square minus 1, which is equal to 3 into x is going to be 3x. To write it in the standard form, transpose plus 3x towards left hand side, then it is going to be x square minus 3x minus 1 is equal to 0. So, this is the standard form of quadratic equation. But is it possible to factorize this by splitting middle term method? It is not possible, because x square into minus 1 is equal to minus 1x square. What are the factors of 1? 1 ones are 1. When you subtract 1 from 1, you will get 0, but it is 3. So, that is why it is not possible to solve this by using splitting middle term method. Then there is alternate, that it is completing square method. Yes, otherwise what is that method? Our formula is also there. No? Better we use the formula, right? Before we use quadratic formula, you will have to equate this quadratic equation with the standard form of quadratic equation ax square plus bx plus c. Why? Because if you compare this, then you can identify the values of a, b, c easily. The value of a is equal to coefficient of x square, that is 1, and b is the coefficient of x, that is minus 3, and c is constant, which is equal to minus 1, right. So, I will write, if you get any confusion, I will write here the values of a, b, c. A is equal to 1 and b is equal to minus 3 and c is going to be minus 1, right. These are the values of a, b, c. After writing the values of a, b, c, you should write the quadratic formula to substitute the values of a, b, c. Therefore, x is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a, right. Let us substitute, which is equal to minus, the value of b is going to be minus 3. So, minus 3 plus or minus square root b square means minus 3 whole square minus 4ac, a is equal to 1 and c is equal to minus 1 whole divided by 2a is 2 into a is equal to 1, right. If you simplify this, you will get minus of minus 3 is equal to 3 plus or minus square root minus 3 whole square is equal to 9 plus 4 into 1 is equal to 4 whole divided by 2 into 1 is equal to 2. Therefore, the roots are going to be 3 plus or minus square root 9 plus 4 is equal to 13 divided by 2. This is the value of x. Of course, if you use plus, you will get one root. If you use minus, you will get other root. This number cannot be simplified further, because root 13 is an irrational number. So, this way we can solve this kind of problems. Okay? And I am going to solve one interesting problem here. That problem is, please concentrate, because this problem is going to be a HOTS kind of problem. Okay? So, what is that problem? Solve for x, that is x minus 5 multiplied by x minus 6 is equal to 25 divided by 24 square. This is the problem. X minus 5 multiplied by x minus 6 is equal to 25 divided by 24 square. Let us think how to answer this, or how to solve this particular quadratic equation. See, x minus 5 into x minus 6 is equal to 25 by 24 square. Definitely we will have to convert it into the standard form of quadratic equation. Okay. Let us try to convert it into standard form. That would be x minus 5 into x minus 6 is going to be x square minus 5 plus 6 is equal to 11x plus 5 6 are 30 is equal to 25 divided by 24 square. Okay, that square belong to only 24 but not 25, right? So x square minus 11x plus 30 is equal to 25 by 24 square, right? Now what do? Do we really use quadratic formula? If you use quadratic formula, b square minus 4ac. Of course, if you don't want fractions and if you simply take LCM, then the 24 square comes here, 24 square into 11 comes here, 24 square into 30 and then minus 25, you will be getting a very huge quadratic equation, right? Then definitely you will have to think logically about completing square method. We used this completing square method in order to derive quadratic formula. Have you remembered? Yes. See, here it is, transposing 25 by 24 square towards left hand side, and then before that writing this into the standard form of one square like a minus b whole square or a plus b whole square. But it depends on the sign of the middle term. So sign of the middle term is minus. So that we can use a minus b whole square expansion in order to convert this as a square number. Okay, right. X square can be written as x whole square. So a square minus 2ab, that is minus 2 into a is going to be x into b. 2 into x into how much is equal to 11x? Yes, that is 11 divided by 2, because this 2 and 2 gets cancelled, x into 11 is equal to 11x. Okay, so a square minus 2ab plus b square, b is equal to 11 by 2, so that 11 by 2 whole square. But 11 by 2 whole square is not there in our expansion, but we want it. That is why we are adding, but for balancing the equation, immediately you will have to subtract it. That is 11 divided by 2 whole square. Now it is balanced and we left with one more number 30, that is plus 30, and anyway transposing 25 by 24 square, otherwise you can leave it 25 by 24 square. If you observe, from here to here is in the form of a square minus 2ab plus b square. A square minus 2ab plus b square is the expansion of a minus b whole square, right? And next, minus 11 by 2 whole square is going to be minus 11 square is 121 divided by 2 square is 4 plus 30 means 30 divided by 1 is equal to 25 divided by 24 square. Okay, let us leave it like this because you want x, that x is located here only. That implies x minus 11 divided by 2 whole square. See, this is plus and this is minus, so that I am using first plus to avoid confusions. 30 divided by 1 minus 121 divided by 4 is equal to 25 divided by 24 square. Okay. If you simplify only these two terms, 4 30s are 120 minus 121 divided by 4. So 4 30s are 120 minus 121 is equal to minus 1. Minus 1 divided by 4. So here it is minus 1 divided by 4, transposing minus 1 divided by 4 towards right hand side. So it would be plus 1 divided by 4. No confusion, right? Okay, that implies x minus 11 divided by 2 whole square equal to 25 divided by 24 square plus 1 divided by 4. Okay, let us try to understand this. 25 by 24 square plus 1 divided by 4. I am not going to change anything. I will just try to simplify this. What is the LCM for this 24 square and 4? I will write as it is 24 square into 4. That is the LCM. And now 25 into 4, I am not going to multiply, but I will write 25 into 4 only. And then plus 1 into 24 square is 24 square. Okay. Now see here, this is 25 into 4 plus 24 square. How am I going to write that? This is x minus 11 divided by 2 whole square is equal to, this is 24 square, right? writing 24 square plus this is 25 into 4, right? I am writing 25 as 24 plus 1 into 4 whole divided by 24 square into 4, and then this is 24 square is 24 square plus this is 24 into 4. So, 24 into 4 is there, right? I am writing it as 24 into 2 into 2 plus 1 into 4 is equal to 4, that can be written as 2 square whole divided by 24 square into 4. Okay. So, finally, x minus 11 divided by 2 whole square is equal to 24 square plus 2 square is a plus b whole square. A square plus b square. If it is a square plus b square, is this 2ab? Yes, 2 into 2 into 24. 2 into 24 is a and 2 is b. So, totally the numerator is in the form of a square plus b square plus 2ab. It means a plus b whole square. But what is a here? A is 24 and b is 2. So, that I am writing it as 24 plus 2 whole square divided by 24 square into 4. See here it is 24 square into 4 is there, no? Can I write this 4 as 2 square? Then it would be 24 into 2 whole square. So, this is 24 into 2 whole square. Hope you understand this conversion, which is equal to 24 plus 2 is equal to 26 divided by 24 into 2 is 24 into 2 whole square. Now, it helps us to simplify easily. See here 2 1s and 2 13s are 26. So, the numerator is going to be 13 and the denominator is going to be 24 whole square. See, the right hand side term of this equality is 13 divided by 24 whole square. It is a simple number. So, easily you can figure it out. So, I am going to erase a few steps of this problem. So, right? Yeah, let me take this x minus 11 by, that implies x minus 11 divided by 2 whole square is equal to 13 divided by 24, 13 divided by 24 whole square. See, left hand side has a square and right hand side has a square. Can we remove both the squares? We should not remove like that, because if I have x square is equal to y square, can I write x is equal to y? It is absolutely wrong. I should not write that. Why? Because if squares of two numbers are equal, then bases may or may not be equal. What is this? Something new, right? So, x square is equal to y square means squares of two numbers. For example, I have 4 which is equal to 4. Everybody knows that 4 is equal to 4. I am writing this 4 as minus 2 whole square and I am writing this 4 as plus 2 whole square. According to what you said here, x square equal to y square, then x equal to y. If I remove both the squares, then I will get minus 2 is equal to plus 2. Is minus 2 equal to plus 2? Absolutely wrong. So, that is why if you want to remove the square, then you will have to put, if x square is equal to y square, then x is equal to plus or minus y. Okay? So, this is very, very important basic point, and moreover, we use this basic point in our intermediate chapter in the concept called functions. There is one function named one-to-one function or injection. In that function, this only x square is equal to y square, then x is equal to plus or minus y plays a major role. So, that is why please be very careful. It looks very simple, but while thinking about this problem, this particular concept, it's really interesting, right? Right. X minus 11 divided by 2, okay? X minus 11 divided by 2 whole square is equal to 13 divided by 24. So, according to our discussion, we can say that x minus 11 divided by 2 is going to be plus or minus 13 divided by 24. You can use first plus 13 divided by 24 and then you can use minus 13 divided by 24. That implies x minus 11 divided by 2 is equal to 13 divided by 24, comma x minus 11 divided by 2 is equal to negative 13 divided by 24. Okay. Let us try to think about this. Then the value of x is going to be 13 divided by 24 minus 11 by 2 will become plus 11 by 2. So, the LCM is going to be 24. Okay. 24, 24, 1s are 24, 1 13s are 13 plus 2 how much are 24? 2 12s are 24. So, 12 into 11 is equal to 132 which is going to be 13 plus 132 is equal to 145 divided by 24. So, this is one value of x. What could be the other value of x? Yes, you can easily say that the other value of x is going to be when you equate x minus 11 by 2 with what is that number? X minus 11 by 2 with negative 13 divided by 24. So, I am going to equate that. Okay. Another value of x and x minus 11 by 2 is equal to negative 13 divided by 24. When you transpose negative 11 by 2 that side, then it would be x is equal to negative 13 by 24 plus 11 divided by 2. Again the LCM is going to be 24 and 24 1s are 24, 1 minus 13s are minus 13 plus 2 12s are 24, 12 11s are 132. Now you are going to subtract 13 from 132, right? Now 12 minus 3 is equal to 9 and now this is 2. 2 minus 1 is equal to 1, already 1 is there. So, negative or positive, it is positive 119 divided by 24. Therefore, the two values of x are 145 divided by 24 or 119 divided by 24. So, this way you can easily find out the roots of this quadratic equation. And let us have one more problem. That one more problem is we already discussed about the nature of the roots, right? Nature of the roots of any quadratic equation depends on the value of b square minus 4ac. So, that is why b square minus 4ac is called discriminant of quadratic equation. And if the value of b square minus 4ac is positive or greater than 0, then the roots are real and distinct. If b square minus 4ac value is 0, then the roots are real and equal. If b square minus 4ac is less than 0 means negative, then the roots are non-real roots and they are unequal. Okay? We will discuss a few set of examples on the concept. Okay? The very first problem is going to be if the roots of kx into x minus 6 plus 3 is equal to 0 are equal, then find the possible value or values of k. This is what the given problem is. Okay? If you observe the problem, if the roots of kx into x minus 6 plus 3 is equal to 0 are equal, when the roots are said to be equal? Yes, the discriminant equal to 0. So, if you want to find the discriminant, our given quadratic equation should be in the standard form, right? So, what is the quadratic equation here? The quadratic equation is kx times x minus 6 plus 3 is equal to 0. Writing it in the standard form just by multiplying these two terms, kx into x is going to be kx square minus kx into 6 is equal to 6kx plus 3 is equal to 0. Now, it is in the standard form. Okay? So, you will have to compare this equation with the standard form of a quadratic equation, that is ax square plus bx plus c is equal to 0 to identify the values of a, b, c. Here the value of a is going to be coefficient of x square, that is k, and b is equal to coefficient of x, that is going to be minus 6 or minus 6k, yes, minus 6k. So, this is minus 6k, and c is going to be, c is equal to 3, so c is equal to 3. After identifying the values of a, b, c, since the roots of this quadratic equation are equal, since roots are equal, if and only if delta is equal to b square minus 4ac is going to be 0. Okay. Substitute the value of b is equal to minus 6k, square means whole square, minus 4ac, 4 into a is going to be k and c is going to be 3, which is equal to 0. Minus square is equal to plus, 6 square is equal to 36, k whole square is equal to k square, minus 4 into 3 is equal to 12 into k is equal to 12k is equal to 0. See, totally how much can be taken common? From 36 and 12, 12 3s are 36. So, 12 can be taken common. K square and k, obviously k is common. So, totally 12k can be taken common. Remaining 12 3s are 36, k into k is k square, minus 12 1s are 12 is equal to 0. So, 12k into 3k minus 1 is equal to 0. Shall we transpose 12k that side? We should not do that, because we are going to find the value of k only. So, that is why you will have to think about the possibilities of the values of k, right. See here, 12k multiplied by 3k minus 1 is equal to 0, means what? Product of two terms is equal to 0. When product of two terms equal to 0, either first term is equal to 0 or second term is equal to 0. 3k minus 1 is equal to 0. Suppose if 12k is equal to 0, if 12k is equal to 0, then the value of k is going to be 0. When 12k is equal to 0, 12 into how much equal to 0? Sorry, k into how much equal to 0, or 12 into how much equal to 0. So, the value of k is going to be 0. This is the first value of k, and the second value of k is 3k minus 1 is equal to 0. 3k minus 1 is equal to 0, then 3k is equal to 1, k is equal to 1 divided by 3. This is one more value of k. Now, can we write k is equal to 0 and k is equal to 1 by 3 are the values of k? We should not. We will have to think about the given problem, that the given problem is kx into x minus 6 plus 3 equal to 0. That is being a quadratic equation. When it is said to be a quadratic equation, we discussed in the very beginning about ax square plus bx plus c is equal to 0, where a is not supposed to be 0. That is the definition. Okay. So, when the value of k is equal to 0, here 0 into x equal to 0, 0 into x minus 6 equal to 0, 0 plus 3 is equal to 0, 0 plus 3 equal to 3, which is equal to 0. Is 3 is equal to 0? Absolutely no. And moreover, there is no quadratic equation if you put the value of k is equal to 0. That is why k cannot be 0. If k is equal to 0, it vanishes the quadratic term. So, therefore, k is not supposed to be 0. Therefore, the value of k is equal to plus 1 divided by 3. This is the possible value of k, right. So, this way we can answer this problem, right. And one more problem is given like this, that one more problem is if the roots of b minus c multiplied by x square plus c minus a multiplied by x plus a minus b is equal to 0 are equal, then prove that 2b is equal to a plus c. This is one of the problems given. If the roots of this quadratic equation are equal, then prove that 2b is equal to a plus c. Since the roots are equal, then easily we can say that b square minus 4ac is equal to 0. B square means what? C minus A whole square minus 4 into B minus C into A minus C is equal to 0. Definitely you will have to square it and then you will have to multiply all the terms. Then you will definitely get totally 6 terms in that expression. So you will have to think a lot. But if you once think logically, we discussed about one special case of quadratic equations to find out the roots. What is that special case? In ax square plus bx plus c is equal to 0, if the value of a plus b plus c is equal to 0, then the roots are x is equal to 1 comma c divided by a. Have you remember this? Correct. In any quadratic equation, ax square plus bx plus c equal to 0, if a plus b plus c equal to 0 means sum of zeros, sum of the coefficients is equal to 0, directly you can say that the roots are 1 comma c by a. But if you want to apply this strategy, the sum of coefficients is supposed to be 0. So what is the coefficient here? B minus c, and what is coefficient here? C minus a, and here the coefficient is a minus b. Okay. So b minus c plus c minus a plus a minus b, obviously 0. Therefore, since sum of coefficients is equal to 0, therefore the roots are alpha is equal to 1 and beta is equal to c divided by a. So 1 is 1 only, but beta is equal to c divided by a. What is c for this equation? Means constant is a minus b divided by what is a? A is going to the coefficient of x square, that is b minus c. But in the problem itself it is given that the roots are equal. The roots are equal means what? Alpha and beta both are equal. So that since alpha is equal to beta, alpha is 1, 1 is equal to beta is a minus b divided by b minus c. By cross multiplication you can say that a minus b is equal to b minus c, right? Transpose minus b that side and c this side, then it is going to be, you have a here and transposing minus c would be plus c. Already you have b and transposing minus b would be plus b. B plus b is equal to 2b is equal to a plus c. Therefore, 2b is equal to a plus c. This way we can easily answer this problem without using b square minus 4ac is equal to 0. So, hope you understand. We discussed few set of examples for quadratic equations as well as for the nature of the roots of quadratic equations. Hope you understand. Thank you.